Okay, alkynes. Alkynes are organic compounds containing a carbon-carbon triple bond. Alkynes are different than alkanes because alkynes are unsaturated hydrocarbons that have less hydrogen atoms than equivalent alkanes. Alkanes are said to be saturated hydrocarbons because they have the maximum number of hydrogens possible. So the rules for writing these out or drawing them out are, if the triple bond is present, you must change the ane to yne, which means ane to yne. The second rule is to keep the triple bond's number as low as possible. Now, here are two examples, ethane and propane. This one here is fuel, regular fuel. This one here is rocket fuel. This one here has the triple bond in between the two carbons with a hydrogen on either side, where this one has the triple bond in between two carbons as usual, but on this side with the hydrogen, like this one, but on this side there is a carbon with 3 hydrogens to it. We are now going to go and look at our first example. Okay, now we're going to look at 2,4-heptadiene. To write this out, we're going to look at the hepta, which regularly would be C7H16. But since it's an yne, that means that it's going to take up some of these hydrogens. But we'll write in the 7 C's, right now. So 1, 2, 3, 4, 5, 6, 7. So we'll start off by just connecting them all. And now we'll look at this. This says that there will be a triple bond in between the 2 and the 4. So, to start it off, 1, 2, okay, so it's going to be in here. There's 1, and the second one will be with the 4. So there. So we have our triple bonds down. Now we just have to write in the carbons where they fit. Like so. That is how you write out 2,4-heptadiene. Because there is the yne in here, it takes out from the regular 16 and only leaves 1, 2, 3, 4, 5, 6, 7, 8 hydrogens. Okay, so here we're going to write out this. To start off first, we're going to look at this here, and it says heptine. So we know that hep, just like the last one, has C7, H16. So, hands off, we're going to write down 7 C's, 7 carbons. 1, 2, 3, 4, 5, 6, 7. Now that we have our carbons down, we can build onto them. We'll look at here, and it'll say 2-heptine. So 1, 2. This is where the triple bond is going to be. Now here is nothing, so we'll put in the hydrogens. And then we'll have to look back up here and see that there is a 4-dimethyl. So that means that on the 1, 2, 3, 4, there's going to be an additional carbon down here with this coming off of it. Don't forget to connect your carbons. And then that is also going to be happening at the C. So we'll count that off. 1, 2, 3, 4, 5, 6. So we'll pop this down here, add on to them, and then we'll add on the additional H's. Wherever they fit, you can put them in. And that is how you write out 4,6-dimethyl 2-heptadiene, which is pretty fun. So now we're going to look at a different one. Now we are going to be naming this. So we'll start off by counting off the C's. So 1, 2, 3, 4, 5, 6, 7. 7 C's. Now we're going to look here and look at this extra thing that slides off. we're gonna count along, so 1, 2, 3, 4. Okay, so 4. And then here is 1, 2, 3. Oops. So 3, 4, and these are diethyl. 3, 4, diethyl. Now we're gonna look where these carbon bond or triple bonds are. I wrote it like this because if you counted it this way, it would show this being 1, 2, 3, 4, 1, 2, 3, 4, 5. 4, 5 is bigger than 3, 4, so we're gonna make this one the first carbon. So starting from that carbon, it's 1, so with the first one, and the last one, or second to last one, sorry, 6th one. And then because there's 7 of these carbons, it's going to count off to be heptane, heptadiene. So heptadiene. So now we just connect this here, and we'll write it out fully as, can I write it? Yeah. 3, 4, diethyl, 1, 6, heptadiene. So that is that big guy right there. That's how you write them out. Okay, let's take a look at this one. Right off the bat, we're going to count the C's. So 1, 2, 3, 4, 5, 6, 7, 8. 8 C's. So that means it's going to be an oct something. So write down oct. Ine, because of the triple bond. So we got that settled. Now we're going to count off to where this triple bond here is. So 1, 2, 3, 4. It's at the 4th thing here. Alright, so I'll put a 4 in front of here and put a dash. Now, we see this thing here, and we're going to check this out. So this is, from here, 1, 2, 3 away from the beginning. So we'll put this 3, and since this is a methyl, we'll put that in. Methyl. So we take these both together and write them out fully. 3 methyl, 4 octine. And that is how you name this big long thing. Alright, we are going to check out this big monster here. Straight away, we're going to count the C's. So 1, 2, 3, 4, 5, 6. 6 C's. That means it's going to be hex. Hex. And because we see this right here, the triple bond, we're going to write in ine. Now, we take a look at this thing right here. This is 1, 2, 3, 4. This here is a methyl. So we'll write out 4 methyl. Now we're going to look at this thing here. 2 carbons. That means that it is ethyl. So this thing, 3 ethyl. Oh, forgot the E. Ethyl. Ethyl. So now we'll just add these on. 4 methyl, 1, since it's at the beginning, 1 hexine. That is how you write out this big thingamajiggy. So that is how you write out alkynes. Thank you for watching the video, and I hope you enjoyed.